We have a presentation from E4. So Giordano Marcini from CTO from E4. Welcome.
I hope you get your dose of carbs that will keep you happy and willing to hear me. And today I'll share with you some of our thinking and the direction that we are taking for enabling the use of AI in a different range of infrastructure and so different range of users. And we heard yesterday that one point about AI is that the workloads are different from the, say, traditional first principle based HPC, and there were stopping points. We had the example of Italy yesterday afternoon, the user in Cinega, that were slowing down the use of AI in the HPC community. First of all, I will speak a little bit about my company that I joined last year. So E4 is an HPC solution integrator. We have been active for the last 20 years, and we have been, I would say, growing steadily over the years. So we could take complex challenges over the year. We were in some projects that included the deployment of some top 500 and green 500 machines, and we are still trying to improve continuously. And in my opinion, one thing that is important for us is involvement mainly in benchmarking, providing resources or co-design roles in European projects for different domains in HPC, from cooling to domain-specific, like in CFD or chemistry. While we do not do usually, from active research, this is very important for us because it increases our, say, situational awareness of what is going on, and so we are ready from what will be next. And some quick, say, success stories about T4. For one example is building with Dompet, that is a company working in drugs, the infrastructure for hosting one of the world's biggest ligand libraries. Another example is already 3 years ago, we built a RISC-V-based machine. And in the last 2 years, we have been involved in the support from the ACWMF and Leonardo supercomputers in Bologna, so 2 of the largest machines in Europe and in the world, actually. And it is not only the iron, of course, and this is one of the main things in my talk today. For instance, and still we heard about it yesterday, we designed the infrastructure that allows the users in Cinega to tap into resources in a classical, say, HPC infrastructure using the batch scheduler. But what the user will experience is something that is not different from what she does usually with his laptop. So a notebook-centric world where interactive computing dominates. And as I say, this is typical of not only OAI, but of any, say, data-centric workload that is not based only on first principles, like, for instance, this morning we heard about Monte Carlo simulations for the trajectory of particles in the high-energy domain. And what I do like a lot is when we have the possibility of designing anything with the customer together, so from the iron, from the Rex to the final solution. I have 2 final examples about it. One is in astrophysics, and is the ASTRI project. This is a project that will be deployed on Mount Teide in the Canarias, and is interesting because it will operate mostly in an unattended fashion, because nobody will be there for most of the time. So we have to allocate for a lot of redundancy. And it will be based on a control plane of 4 nodes, and these 4 nodes will operate both the servers that control the Chercon telescope and a Kubernetes clusters that will do real-time analysis in place, because there is a continuous stream of data from the telescope that must be sorted out on the spot. and storage and other resources that will be used by the users in Italy and remotely to run their jobs. And another similar example that still integrates all of our portfolio is the SAM project, and it is analogous in this case. Also, the users were willing to use our platform that I will show later to do their machine learning models running about geology. So before going to what we try to do, I'll show you some thoughts. These are mostly known things, but just repetita iuvant, so I will go very quickly over there to set the landscape. One thing is that the models are a tiny part of the actual ML model, AI model will be just a tiny part of the whole ecosystem. And when you go from experimenting or learning from a POC to production, there are a lot of things that you have to take into account about the security of the data, the regulatory compliance that is very important in Europe, and the general reliability of all the components of the ecosystems. And so all these things will affect how you design the iron that is running it under. Two other things is that if we go to the hotness of AI, that is the LLMs, there are a lot of public or non-public LLMs that are continuously being published with different strengths and weaknesses and different advertised features. They will continue to grow, and probably we will see more complex patterns emerge from these giants. But it is unclear right now if there will be ever a dominance of one or few models over the other. So if you have to use these on-premise and use their APIs, it's difficult. You have to take into account that the situation may change a lot very quickly. And this is even more true when you think of the tools that you use for the LLM, like LangChain. These things keep changing continuously, and there is no city point that is arriving. And another thing to consider, this is I'm not an AI expert, so perhaps I'm stepping out of my comfort zone, but first, it is not automatic that giant models will be the solution to everything. And for instance, there are some studies, like the one on the right, that say that some of these giants are actually undertrained, and with fewer parameters and more training, we could do better. That is the chinchilla point. And another interesting thing is the fact that we could use different models together, and the mixture of experts approach. From the user point of view, the application, this is very interesting. But from the poor sysadmin point of view, it gets more complicated because I will have to allow for more flexibility in the infrastructure, and this will increase the complexity of my work. And of course, there is the problem that I can be energy constrained. So I have to monitor what my users are doing, if they are allocating their resources in the best way, because there will be a lot of competition. And not only it's not only the energy bill, because the energy may be the same, but the carbon footprint may be different, and I may be asked to account for it partially. And if you think that I've not mentioned it before, but if you want to use agents, latency may be very important. This is another, stress factor that the infrastructure that you want to build has to account for. So how we, with our possibilities, try to address this? Let's start from just an abstract example infrastructure that is kind of, for us right now, a sort of reference architecture. We will have different, some control plane that actually for us is based on OpenStack. and physical layers of networks and other things. And then some resources that may be different because they are were bought for different purposes and may have different constraints for competition and so on. And so how I cannot just do a static photo and say this will be the best layout for 3 years. I could do that some years ago, but now it's very complicated. And so I may have one situation in which there are no big complications because my user run constant workloads that are not very data-centric. There are few bottlenecks, and so for them, they will be happy if they just continue to use the scheduler with this LEI and be happy with that. But if the situation is more complex and I have to allocate for more users than I have resources, that happens usually, then I must be able to redefine the purpose of these resources. For instance, we have one case in which at some point some user wanted to run genomics workloads in a very restricted and secure way. And so we have to automatize the way in which some nodes were taken out, reconfigured quickly. The jobs would run for some weeks, and then they were put back in the general pool. And so to do this reconfigurable HPC, we use most of the tools that you see here. So the basis paradigm is a private cloud, and we use automation tools to do the configuration. We distinguish the part most near to the metal, for which we do the most of the work, and some part that we leave more freedom to the users to use containers and deploy, not only run their own applications. To do that, we mostly do use community solutions, but we do have something that says an internal project just to speed up the things. So we do maintain a small Ansible collection that when we deploy an infrastructure, we usually release to the customer, because it will be the description of their iron, and so they will want to keep them and use them even without us if they want. And to automatize the generation of inventories and the documentation and all the needs that an automation tools needs, we have this internal project called Talos. That it is it is a series of scripts mostly in Bash and Python that interrogates basic resources in the IBM AI and other data sensors in the machines. For storage and small actions, we do use a lot BGFS, and we also personalize some monitoring solution based on a common stack like Prometheus, Grafana, Logi, and the normal tools that we use in general in monitoring and alert management. And also, we have this more general and powerful solution for monitoring and operational analytics that is called Hexamon, that is exascale monitoring, that was deployed in Cinega, I think, since the Davide machine, so it should be 2016, 2017, and it was then deployed on Galileo 100 and Marconi 100. And so it was the general architecture is very flexible. It can scale horizontally. So if you had resources, it can manage many nodes up to, in the case of Marconi 100, I think that it was at the most 5,000 nodes and 1 million sensors. And it can ingest data from the operating system, from the iron, so the IBM AI or other monitoring tools, from the PDUs, or from the general environment. So you can really, with all this data, create, if you accumulate for enough, a digital twin of your data center. And you can also get data from the scheduler. That is, currently we can get data from either SLR or OpenPBS. And so in this way, you can do two things that I mentioned before. First, you can correlate the energy bill to your jobs and see how really a job is costing you in terms of energy. And also you can, if you accumulate enough statistics, the description that you have of the jobs that come from the scheduler are text. And so it is doable that you embed it in a model, in LLM. And so you can try to do some forecast and see if you can optimize what the scheduler does with policies, or spot some unforeseen behavior, so do real-time anomaly detection. And this is, if we go to the beginning, is very important, because in this way you can try to do the most that you could do given your resources that are not only the iron, but also how you operate it. And so this is okay just for HPC. Even if I don't want to deploy any AI model, any LLM, all these things would still give you the flexibility that with which an experienced administrator that may not need to be the administrator of the machine could do some reconfiguration. And so the idea, we are not there yet, is that as we heard this morning, users should be able to ask for a clusters, not for resources for a job in the future. And on top of that, we can deploy something that is really in the notebook-centric world, and is an enabler for users that do not need any experience in HPC to run AI model. And of course, Urania is this solution, and it is based on Kubernetes. Right now is on, we use RKA2, but there is an ongoing reflection about it because we could do the integrated better with Medusa, but still we are a small team, so it's not easy to keep up with all the things that are coming. And we use the, for instance, the NVIDIA operator for the network and the GPUs to expose directly the computational resource to the container. So it is not really different for a user that in their experience. And on top of it, we have the tools for managing a Kubernetes cluster that has to do AI at variance with, I don't know, web microservices. And so there are some things that are specific, like Vulcano or Mini.io, and allow to create really a ready environment, a turnkey environment, as it is in the title, to be up and running. And so with this, you can have on the same pool, and you can switch the weight as you want in, say, a matter of some hours, from a traditional pure HPC purpose to an AI based on orchestration infrastructure or a mixture of the two. And we are also integrating directly, because Urania will expose to the user a series of environments like code editors, notebooks, operators for specialized like Spark or Dask. And we are also integrating in it tools to from the LLM APIs, so to help directly the generation of function, the generation of documentation. And so it is really, and this is all done on-prem, so you don't need, if you need it, to worry about security, because in theory, I mean, once you start base yourself on a foundation model and you do your fine tuning, your RAG you could put it out of the network until you need more training. And this is what I wanted to show you. Just a few final remarks. That is about what I've said before. That one thing that is important, in our opinion, for on-premise AI is that has advantages for fields of application like the agents, is the control of the model and the latency. And in this, having an on-prem infrastructure it's very important. And then, as I said, perhaps we are now in a phase where the get traction phase of AI is being over, because there will be the enthusiastic moment, the general stupor of the even say like users about its potentiality, but we are now not more. I mean, it is not given that we should use general models in the public cloud to do everything. We probably should focus on more serious applications. I want to thank you, the organizer, for having me. I hope that your digestion went well and you didn't fall asleep. So the day for lunch was okay. And so there are some questions I'll try to answer.